We're going to do lessons 14 and 15. We're going to look at nets and surface area. We kind of talked about what a net was before. We're going to draw some nets, and I'm going to show you some nets as well. And there will be a link for you to pull them up while you're working on the lesson. If we were in school, obviously this would be a lot of fun to go through, but some of those other links would help you with taking through and making some of your own. So today's goals. So get these icons down. I can match polyhedra to their nets and explain how I know. When given a net of a prism or a pyramid, I can calculate its surface area. I can calculate surface areas of prisms and pyramids. And I can draw the nets of prisms and pyramids. So make sure you get all your information down before we move on, and let's get moving on. So I'm going to use this handy website here real quick to kind of show some things with looking at some polyhedrons. So I've got a square pyramid, as it says up here. You can see as a solid, we have on the bottom here, we have a square face, which is how it gets its name. And then we have that it comes to a point with all these triangles on the side. So this would have 1, 2, 3, 4 triangular faces and a fifth square face. If we talk about the net, the net is kind of an exploded parts. The piece or the three-dimensional figure taken apart. The net really is this, and let me take that off. So the net is what it would look like if, oops, hang on a second here. The net is what it would look like if you were to cut this out on paper and fold it together. So when we cut this out, we could fold all these pieces up together and use that to create our solid back together. Okay. Here we have a triangular prism. You've got those rectangular faces, and then we have a triangular face and a triangular face. And I know that it may look like that this back here is smaller, but remember, this is perspective, so it should look like that we should have a triangular face that looks larger because it's closer to us. If we look at the net of this one, again, we've got those triangular end pieces, and then we have our, in this case, square side pieces that we would fold together, and we could tape all those pieces together. One more, we have a cube here. Cube we know has 6 faces, and each of those faces is a square. If I take and just show the net on this, the net pieces would look something like this. So what we would do is we would fold these 3 parts up, we'd fold this over and fold it again to make it into the cube. Let me take that net off there. So it really is just a matter of putting 6 squares together to make that piece. Oops. Okay, let's dig back into our lesson. All right, take a look at these. What we're going to do is I'm going to have you guys match them up now that we've looked at a few of these. In fact, a couple of these we directly did back just a few moments ago. So see if you can match each of these with the number with the letter. Okay, so if you got this completed, you should have, let me get a handy color here. So for number 1, as I look through here, I think that that would have to be letter E. Oops, would help if I had the right drawing tool. So letter E would definitely fold up into that. We've got those square faces that fold up and move around to make that cube. Number 2 is very similar to number 1, but we've got rectangular faces with square end pieces. So this would have to be B. Straight above it would fold up to make number 2. Number 3, we've got a pyramid. We have a square base. So we need to find one that's got a square base with triangular faces, and that would be A. Number 4, we've got another pyramid, but this time it looks like we have a triangular base. So we're going to make a triangular pyramid, and that would be C, because we have a triangular base. These would fold up to make the sides here. And the final one, we've got a prism again, but we have a triangular prism. So we're going to look for rectangles that have a triangle with it, which would be in letter D. So I hope you got all those pretty well. I know that it is difficult to do this, figure these out through video, but you're doing great. Okay, as much as I would love to cut out and hand these each to you to figure out, if you have a piece of graph paper around, you could draw these out very similarly and create them as well. And what you're going to do is we're going to answer a few questions real quick with each part of this and go through and do this together. Okay, as much as I'd love for you to cut these nets out and create the three-dimensional shapes, that's not going to happen. There is a link on the side for you to see some of them and possibly print out your own if you've got the opportunity. But if we look at number 1, or if we look for number 1, the name of each one. So if we look at A, what do we have? Yeah, we have a rectangular prism, right? We've got 2 giant rectangles, and then we have 4 smaller rectangles that connect those larger rectangles together. B is a square pyramid. We've got a square base and triangular sides that would fold up to make that triangle, or to make that pyramid. D, we actually have, if we look at this one, we make a, again, prism, but this is a triangular prism. These sides would fold up, and then we would fold both those other pieces together and tape on the end and give us a triangular prism that way. It would be a unique one. Okay. So what do we find for areas for each of these? Well, again, it's one of those things where we have to think about them in pieces and put that together. So if I look at this end piece here, I've got 1, 2, 3, 4, 5. So it's 5 by 1, so 5. So each of these is 5. Okay, so I have 4 5s, and then for my big triangle, or big rectangles, excuse me, tangled. I've got 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. So that gives me an area of 30 here. So if each one of those larger ones is 30, and each of the smaller ones is 5, 5, 10, 15, 20, 20 plus the 30 gets me 50. 50 plus the other 30 gets me 80 square units for the surface area. Okay. Same sort of thing here, right? Should have 1, 2, 3, 4 by 1, 2, 3, 4. So that gives us 16 for the bases area. And then I have 1, 2, 3, 4 for a base, and then 1, 2, 3, 4 for a height. So half of that would give me 8. So each one of these triangles is 8. So if I put my 4 triangles together, 4 times 8 would give me 32. 32 plus my 16 would give me 48 square units. Last one's not too bad. We've got right triangles here, so that makes it not too bad. Let's see. Surface area, I've got 1, 2, 3 by 1, 2, 3. 3 times 3 is 9. Ooh, that was terrible. No! Wait. Okay, I got it back. Let's see. So I should have 9 for the area here. I got 1, 2, 3 by 1, 2, 3, 4. That should be 12. I've got 3 by 1, 2, 3, 4. So that should be 12. Half of 12 is 6. This one matches it. It should be 6. This is a longer rectangle than that one. 2, 4, 5 by 3 should give me 15. Add all these together. Let's see, 6 and 9 together is 15. 15 and 15 together make 30. 30 plus 12 is 42. 42 plus 6 is 48 square units as well. So even if we can't interact with these, we can still see how they make their areas, their surface areas, without actually even, put them together. So building prisms and pyramids, today we looked at a few things with finding surface area. So as much as I'd like for you guys to make some, we're just not going to be able to do that. So let's talk about a few things. One, how do we use nets to find surface area? Well, they give us those flat spaces to figure out the area and add those together. Surface area of a net, different finding a surface area on a picture, like we had done with that filing cabinet, or if we use with the snap cubes. It's really not too much different, except that with the using the net, we can actually draw it out onto something and physically look and count pieces instead of just counting on measurements. Okay. Using a net, how do we keep track of our calculations? Personally, I like to write them next to, so that way I can figure things out. You can write them directly on it. You can label everything out when we're using a net much more easily than you can, especially if it's an actual figure that you wouldn't necessarily be able to do that on. And simplify our calculations. We just need to kind of find the area of each part of the polygon one at a time, so that way we can find our total. And I think we prove that if we have the measurement pieces, that we can, knowing what we know about how to find area of triangles and rectangles and parallelograms, knowing what we know about those, we can find the surface area of any prism or pyramid from a picture without necessarily having to handle it. As long as we've got the measurements that we need, we know that those shapes continue back on the other side. Like if we go back to what we started with originally, this rectangle is the same as the other 3 rectangles around it. So if we find one area there, then we just need to find the other 4, or we just need to make it times 4. Same with the squares and the ends here. Same with the triangular pyramid. If we know the area of the base, and then we can find that the other 3 triangles, in this case, those are all the same size triangle. It doesn't necessarily happen that way. But as long as we've got parts that are duplicated, it makes it a lot easier, because then we really only need to find one. On a cube, it's the easiest. We find the area of one of those faces and multiply by 6. So thanks for watching, and hopefully this made some sense with it, and we'll be able to interact with these soon enough, someday soon.